Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this edition, we're looking at the 2025 June exam. This is the one that was written in KZN for grade 12 learners. And we're going to be looking at question 1, which covers statistics. So let's have a look at the question. So the question reads, the box and whisker diagram below illustrates the distribution of mathematics June examination marks out of 150 for a class of 32 grade 12 learners. Very important. The median marks is 65 and the mean is 71.5. So we're given the box and whisker below, and we are required to, if you look at 1.1, we are told if none of the learners had a mark of 90 over 150, how many learners had marks higher than 90? So we need to note something important here for 1.1, which is that if you observe carefully, our Q3 is 90, and if you look at our Q1, which would be sitting here, that is 47, and if you look at our Q2, which is our median, that is what you call it, 65. So there's something that I need you to remember about the box and whisker in general. So let's quickly draw one here. Let's have this one and then have our median somewhere here. Okay. So there's something that I want you to remember about this diagram, and that is what we have as the first branch here, that would be our minimum. Then we have our Q1, then we have our Q2, Q3, and then we have our max. Okay. So one thing I need you to remember is the following, which is that if you look from your from your minimum to your median, what you're looking at is about 50% of the data. Okay. From your minimum to your median, then from your median to your maximum, you're looking at 50%. Okay. And then what then I need you to remember is that from your Q1, from your mean to Q1, what we're looking at is about 25%. Okay. So from here to about there, that is 25%. And then from here to there, that's also 25%. Then from here to there, that is also 25%, which means from, if you look carefully, Q3 to the maximum, that is also 25%. Okay. So now, if you look carefully, Q3 will be at 25% of the maximum. So now, if you look at our data, they are saying we are looking for learners who got more than 90, and at Q3 we have 90. So meaning any number of learners, 25% of above 90, that would make up what you call it, the number of learners who got 90 and above. So what this means is we just need to go and take 25% of 32, okay? Because it's only 25% of the population that is above 90, okay? So that means we're just going to do 25% multiplied by 32. So let me quickly use my calculator. 32 by 0.25. And what we end up getting is 8. So what this means is we have 8 learners who got more than 90. So let's quickly note the answer. And the answer is 8 learners got more than 90. Okay, more than 90 over 150. So that is our answer for the first question, 1.1. Now let's have a look at 1.2. So in 1.2, we are concerned about the skewedness, okay, or the skewness of this data. So how we determine skewness is in the following way. Okay. So what I'm going to do to you, I'm going to present you with something that is positively skewed first, okay? And other people usually call it, they usually say it is skewed to the right. So let's create some space there. So these you must know very well so that when they ask you these questions, you know how to answer. So when they say something is skewed to the right, this is the kind of box and whisker which you will usually find, okay? So you'll have that there, then you'll have this. Then when it's skewed to the right, what will happen is it will be something like this, where you have more space to the right of the median, which is Q2, okay? So remember that what you have here, that is your Q2, Q1 here, Q3, then we have our max and mean. So this positively skew here, when does it happen? Well, this happens under two conditions. Okay, so it happens under two conditions. So the first condition is if you observe carefully, if our median, which is known as Q2, if that is less than our mean, not mean, but that is less than our mean. Let's move this. So if our median is less than our mean, of which our mean is usually denoted by x dash, then that is going to happen. Or alternatively, that is if you look at the gap, if you take Q2 or Q3 minus Q2, that will be less than Q2 minus Q1. So another check you can do is you can say Q3 minus Q2. For positively skewed data, this will be greater than Q2 minus Q1. Okay. If one of these conditions is true, then this will be positively skewed. So we need one of the conditions to be true. Okay, so that is what happens with positively skewed data, guys. Now let's have a look at negatively skewed data. Okay, this will usually be also called skewed. They will say it is skewed to the left. Okay. So when they say the data is skewed to the left, how can we tell? By looking at our box and whisker. So I'm just going to copy the one I have above. So all what will happen is it is the inside that will change. Okay. So we have our Q2. Let's remove, sorry, want to delete this line. So what will happen is if it's skewed to the left, then our Q2 will be more to the right, such that on the left, we have more area, okay, compared to the right. So this can also happen under two conditions, okay? So this is going to be skewed to the left if our median, which is Q2, let's make some space. If our median Q2 is greater than our mean, okay, which is denoted by X bar, or if our Q3 minus Q2, if you observe carefully, this is very small. It is small compared to Q2 minus Q1. So you can check any of these two. Then we have symmetrical. What do we mean? Well, let's go and have a look at symmetrical data. So if we have symmetrical data, what happens is the following. So let's paste this. Let's delete this. So what you will find is that our Q2 is exactly in the middle. Okay. So our Q2 becomes exactly in the middle. Q2. Then what you will notice with this one is that our mean will be equal to our median. So if your mean is equal to your median, then your data is evenly or symmetrically, it is symmetrically spread. Alternatively, what you can see is you will see that your Q3 minus your Q2 should be equal to your Q2 minus your Q1. Okay, that will speak to symmetrical data. Now to the question. So now let's go and answer the question. So if we look at our question, we're looking at 1.2. So we were told that the median is 65. Okay. So we know that the median is equal to 65. And we are told that the mean is equal to 71.75. Okay. 0.75. So if you observe carefully, you will see that our median is less than the mean. So when our median is less than the mean, then what does it mean? Well, let's go and look. Median less than the mean. So that is negatively skewed data. And even if you look at the what do you call it? Sorry, I'm looking at the thing. So the mean is greater than, so this one is not correct. So the median is less than the mean. So that is positively skewed data. So you'll see that as long as the right-hand side is a bigger portion, then that becomes positively skewed. So we can therefore go and conclude, looking at the notes we made there, that this data is positively skewed. Okay, someone else would have said skewed to the right or skewed to the right. So this is what one of you would have written, and this would be equally correct. Okay, so I hope that this does make sense, guys. With this in mind, let's go now and figure out what is the range. This is 1.3. So we have 1.3. And there we're looking at the range. Okay. So for the range, remember we need the maximum and the minimum. So we need to ask ourselves, what is the maximum and what is the minimum? So if we look at our problem, the minimum is always sitting here, and that is 34. So you'll see that our minimum is 34. And then our maximum will be, let me create some space here. Our maximum will always be, when you look at your box and whisker, what is here, which is 125. So we have 125. So now finally we can do our range. And our range is always given by our max minus our mean. So this is 125 minus 34. So therefore, for this problem, we can establish that our range is going to be 125 minus 34. Let me confirm. Yep. So our answer ends up becoming 91. Okay. So that becomes our answer. Okay. So let's have a look at what they are saying. So they are saying there is only one candidate who had a mark of 125 out of 150. On checking the answer book of the candidate, it was discovered that a mistake was made when adding his marks. The mark was corrected and it was changed to 142 out of 155. So his mark was increased. Okay, it was at 125 and then he went to 142. So now we are required to determine the median. Okay, so remember, the median is the center of the data. So the number of students did not change, but it's just the data that changed. It's a data point somewhere there. And that data point, remember, it's above 90. Okay, so it means now all what we are changing is the maximum, because if you observe carefully, this was 125. Now the maximum will be at 142. Okay, so let's go ahead and deal with this problem where we are looking at 1.4. So in 1.4, I'm going to have the same box and whisker. Let me quickly draw it. So we're going to have something like this, and it is skewed to the left. And what we are going to have is exactly the same setup. So we're at 34, and then here Q1 with a 47. Let's maybe put it below here. Q1 with a 47, and then the median, sorry, that is 65. And then we have our 90. Then now our maximum has changed to 142. So that just becomes 142. Okay. So now we can deal with the median. So the median shouldn't change because all what really changed is this, because we didn't increase the number of students. So 1.4.1, that median should remain as it is. So it will be 65 as it was. Okay, done with that. Now let's have a look at 1.4.2. So 1.4.2 requires us to figure out the mean. Okay, so let's go and have a look at how do we find this mean here. Remember, mean is given by x dash. Okay, so we know that x dash was given by the sum of the terms. Sum of terms divided by n. Okay, that is what we had. But now what we need to realize is that the sum of terms has actually increased. Okay, so what we've done is we've increased what we had by, if you think carefully, by, so if you look carefully, we'll look at the increase in marks. So this person is now 142, they were moving from 125. So the increase will be 142 minus 125, that will be 17. Okay, so now if you think carefully, I can now go ahead and find the new mean. Okay, so I'll call it new mean. So if you think carefully, what we had here previously, this was the old. So what this gave us was the old mean. Okay, and that old mean we were given as 71.5. 71.75. So what I can do, since there's an addition of 17 and the sum is just increased by 17, it means I can do my mean, which is 71.75, and then plus the increase is 70 divided by n. So remember, we're dealing with 32 learners. So this should give me the new mean, because it's the same as just doing the summation there with now 17 extra. So this means our new mean will be equal to, punch, 71.75 plus 17 divided by 32. And what we end up finding is 72.28. Okay, so we're getting 72.28. And this is what we end up having as our new mean. Okay, I hope that this, guys, does make a lot of sense. There's a couple of steps that someone else would have undertaken here. So let's explore them. So I'll say here alternatively. So we'll have a look at an alternative method below. So someone else would have said, okay, we know that the mean is given by the sum of the terms divided by n. So we know that we have 71.75 equals the sum of the terms divided by 32. Okay. So we can find the sum of the terms, that person would have argued, by taking 71.75 and multiplying it by 32. Okay. So 71.75 multiplied by 32. And what we end up finding is 2296. So it means the sum of the terms was 2296 before. Okay. And remember, now the marks have increased. So remember, the total mark, that total mark increased by 17. Okay. So this means now I'm going to find a sum, but I'm just going to call it new. Okay. So it's going to be this 2296 plus 17. So let's add 17. Then what we end up getting is, as our sum is 2313. So now we can go ahead and find our new mean, whereby we are going to use our new sum, and this will be divided by n. So this means we are going to have 2313 divided by 32. So this is going to be divided by 32. That becomes 72.28. Okay. And if you observe carefully, this is exactly the same answer as what we found previously. So lock in, guys. Try and make sense of these questions. They are very simple if you do apply yourself. So please share this awesome lesson with others, be it classmates which you like and you want them to pass, or your friends. This is brought to you by iCampSA. And once again, this is the KZN 2025 June exam, question 1. Cheers, guys.